When people hear about something like the Phoebus Cartel, they often assume it was a law. It wasn't. It was a private agreement between corporations. Major light bulb manufacturers agreed to standardize product lifespans to roughly 1,000 hours. That decision influenced global manufacturing standards. It was not legislation passed by a government. There's a difference between corporate coordination and public law. Cartels operate through market dominance, contracts, and industry pressure. Laws operate through democratic or state authority. Understanding that distinction matters because when industries normalize something long enough, people begin to believe it was always legally required. Often, it wasn't. An industry standard is not automatically law. A group of companies can agree to manufacture products a certain way. If they control enough of the market, that standard becomes widespread. Over time, it feels permanent, it feels official, but influence is not the same as legislation. In the case of the early 20th century light bulbs, lifespan limits were enforced through corporate agreements and economic penalties between companies, not through criminal codes. When we study business history, we have to separate regulatory law from coordinated corporate practice. They are not interchangeable. When a small number of companies dominate a market, their internal agreements can shape global behavior. That doesn't mean the public voted for it. It doesn't mean a parliament passed it. It doesn't mean it was written into constitutional frameworks. It means supply chains were controlled. If nearly every major manufacturer follows the same production standard, consumers have no visible alternative. Over time, people assume that standard is natural, technical, or even legally required. Market dominance can create the illusion of inevitability, but inevitability and legality are not the same thing. Corporate governance is internal. It governs shareholders, boards, and production decisions. Public governance governs citizens. When a corporation or consortium makes a decision, such as limiting product lifespan, it affects the market, but it does not automatically become law. Confusing corporate power with state authority leads to distorted conversations. Critiquing corporate coordination is not the same as claiming governments mandated it. Precision matters when discussing history, economics, and sovereignty. If we mislabel corporate behavior as law, we lose analytical clarity. Some harmful standards are enforced through legislation, others emerge from concentrated corporate influence. When we study cases like the 20th century industrial cartels, the evidence shows private agreements shaping global norms, not criminal statutes forcing shorter light bulbs. Understanding the mechanism helps us design better alternatives. Carbon filaments operate at lower temperatures and produce softer light, but they could last significantly longer under stable conditions. Lower voltage, lower heat stress, fewer on-off cycles. Heat cycling is one of the main reasons filaments fail. When a bulb is switched on and off repeatedly, the filament expands and contracts. Over time, that stress causes breakage. Long-lasting bulbs historically operated more gently, sacrificing brightness for endurance. Longevity was a design choice. Modern incandescent bulbs historically shifted to tungsten filaments because tungsten can operate at higher temperatures, producing brighter light and greater efficiency per watt. However, higher temperature means higher stress. Higher stress means a shorter lifespan. In the early 20th century, manufacturers converged around roughly 1,000 hour lifespan as a practical commercial standard. That number became normalized across markets. It's important to understand lifespan is a balance between brightness, efficiency, material limits, and economic design decisions. It isn't magic, it's engineering trade offs. The Centennial light is the most famous example, but it isn't the only running bulb documented from the early 1900s. There are additional historical cases of long-lived carbon filament bulbs in firehouses and municipal buildings, particularly where lights were left continuously on at low power. Continuous operation reduces thermal shock. Stable voltage reduces filament fatigue. Lower brightness reduces evaporation of filament material. When those conditions are controlled, lifespan increases dramatically. Durability correlates with design restraint. Market standards shifted toward shorter lifespans in the 20th century. Durability and brightness are trade offs. The takeaway is practical, not dramatic. If we want long lasting objects again, we design for endurance instead of maximum output and rapid replacement. Engineering decisions shape lifespan, and lifespan shapes culture.